All right, let's go ahead and get started. Welcome to our webinar today. My name is Justin D'Souza. I am a quantitative analyst and statistician here at Statistic Solutions. So today we are going to discuss how to construct quantitative research questions and hypotheses. And by the way, if you guys cannot hear me, just let me know. Just shoot a message in the chat box if you're having audio difficulties, and we'll try to resolve those. So yeah, let's go ahead and get started. So before we dive into the topic today, I just want to give a brief overview on what Statistic Solutions provides in terms of services. So we help with virtually every portion of dissertations and theses, starting with topic development, prospectus and concept papers. We help with the proposal chapters, so introduction, literature review. We help you select articles. We help with both quantitative and qualitative methodologies. So in that section, we'll help you develop research questions and hypotheses, which is what we'll be discussing today a little bit. And we'll help you formulate data analysis plans so we can figure out how you're going to crunch your numbers. We'll provide sample size estimates so you have a good idea of how many people you need to target. We also help with IRB forms, data entry templates. We have our own SurveyMonkey account. So if you need help uploading and hosting your survey, we can do that. And we also help with results chapters, both quantitative and qualitative, as well as discussion chapters, PowerPoints for proposal and final defenses, and journal publications. So the way that our company works, we'll assign a methodologist to you, and we'll assign a literature review specialist. So they are specialized in those respective areas of the dissertation. Okay, and at the bottom here, I have a link that I will send to everyone who joined the webinar afterwards, in which you can schedule a free 30-minute consultation with our production manager, and you can discuss where you are in the process and where you feel you need the most assistance. Okay, so let's dive into today's topic. So we're discussing primarily quantitative research here, and how to develop those research questions. But before you get to that point, you have to lay the groundwork. So here we discuss what is the difference between quantitative and qualitative research. Quantitative research involves collecting numerical data. You're able to statistically prove hypotheses in general, whereas qualitative research is more open-ended. You're examining the underlying perceptions of participants. It's more suited for an interview format, whereas quantitative is more closed-ended responses. You're not looking at perceptions or open-ended perceptions. You have closed-ended responses on a survey. Okay? So before you begin developing your questions, you need to first go through the literature and develop your research problem. You need to identify a gap in the literature. And this is an important step because in my experience, I've helped numerous clients who kind of jump ahead to develop research questions, and they start looking for surveys and they start looking for archival data, and then they work backwards. They work backwards to fill the gaps in the literature. So you really want to develop, you want to find that gap in the literature first, so it is supported in research that needs to be conducted. You don't want to arbitrarily create research questions without the gap in the literature. Okay. So after you've identified your research problem and the gap in the literature, you want to create a list of all your variables of interest. If you're doing a quantitative study, then obviously these need to be numerically measurable constructs. Something that could be measured on a survey, something that potentially has a range of possible values, discrete values. So in this case, you want numerically measurable data, and you need to identify if you're going to measure this data through a self-report survey, or are you able to find this data online through an archival or secondary source? Okay, and in my experience, if you use a self-report survey, you want to use something that is previously validated. That's highly recommended. Obviously, there are some studies where you are developing your own survey, but that comes with its own hurdles. You have to prove that that survey is valid and reliable. Okay, and I do see I'm getting some questions already. I should have mentioned at the beginning, I'm going to go through the whole presentation, and at the end, I will look at the questions that are being asked. So you can type those into the chat box, and you can raise your hand as well. And I will unmute you at the end, and we can discuss one-on-one. So yeah, you want to find a previously validated survey. You want something that is reliable. It's the most efficient way to get through the dissertation process. If you have to develop your own survey, you have to pilot test it. You have to run exploratory factor analyses, maybe confirmatory factor analyses. You have to prove that that tool is in fact reliable. I would highly recommend looking for a self-report survey that is validated, and or use archival data, so a data set that already exists. Okay, so in the next section, still a little bit before we get to developing research questions, you need to identify what is your quantitative design. And identifying your quantitative design is going to open up the possibilities for what your research questions can be. So what I've listed here are the 4 most predominant research designs that I see when working with students on dissertations. So you can have a descriptive exploratory design. You can have a correlational design. These 3 kind of go together: experimental, quasi-experimental, causal, comparative, and longitudinal. Now, each of these components will have a different phrasing for how you list your research question and hypotheses. Okay, so we'll start out with the most basic. So you can have a descriptive or exploratory design. And in this case, if you're just doing a descriptive design, you don't necessarily have to prove or disprove hypotheses. It's more trying to describe trends in your sample. So maybe you give a survey, or you're looking at archival data, and you're just trying to describe the characteristics of the sample. You're not trying to prove that there's a relationship between variables. That would be an exploratory design. So I've given a sample research question of what these look like. So what are the trends in job satisfaction among teaching faculty? We're not connecting job satisfaction to another variable. We're not looking at differences based on gender or ethnicity or years of experience. We're just exploring the trends among the sample. Similar to the second research question, maybe you're using the MLQ, which is a leadership questionnaire, and you would ask, what is the predominant leadership style used among managers in the workplace? So this would be also exploratory. You're not connecting leadership to another factor. It's just trying to describe how the leadership style is amongst a sample. So questions like these are usually addressed by using descriptive statistics. You're not using correlations, you're not using regressions, ANOVAs, you're just describing the trends using frequencies and percentages, or maybe means and standard deviations. So if you're, another example would be if you're just trying to examine or what are the trends of demographics in a certain sample, that would just be giving potentially gender, age, ethnicity, race for your sample. And that is descriptive. You could just use frequencies and percentages or means and standard deviations to summarize those findings. Now, exploratory designs, they could be considered too simplistic for dissertation research. I've done some studies that followed this path, but many committees will say, no, we want you to run inferential statistics, meaning correlations or ANOVAs, things like that. But it might not be a bad idea to have one research question that just explores the trends in the survey. Okay, so our next research design is a correlational design. Now, correlational research is an umbrella concept. So it's an overarching concept that encompasses both correlational analyses and regression analyses. So correlational analyses are two-way relationships, and regression analyses are predictive relationships. So that correlational design can apply to both of those types of analyses. So we'll start with correlational analyses. And when you do this type of analysis, you don't need to have independent and dependent variables. You just need two variables of interest that you're trying to connect together. So you don't need to have one variable being dependent on the other. It's generally a two-way relationship. So a correlational research question typically has the following format. And this first one here is just a general template. So you would say, is there a significant relationship or association between X and Y? It's usually just two variables when you're doing a correlation. And then we have some sample questions here. Is there a significant relationship between age and self-efficacy? And likewise, how I said that you don't need independent or dependent variables, you could invert those two variables and it would not matter. You could say, is there a significant relationship between self-efficacy and age? When you run a correlation, it works the same way. So it doesn't matter what order the variables are. So there we have two numeric variables, age and self-efficacy. Just imagine you use a questionnaire, a Likert scale questionnaire to measure self-efficacy. And the second research question, is there an association, significant association between education and job position? So that would likely be two categorical variables. Education, maybe it's less than high school, associates, bachelor's, master's, PhD. Job position, there could be a variety of positions there. Manager, executive, employee, things like that. So with that understanding, you can determine what analyses you would need to run. So if you have two continuous level variables, you would run a Pearson correlation. And that would likely be for this first sample question. If age was a fill in the blank response where the participants actually entered their age, and self-efficacy is measured through a Likert scale questionnaire, then you would use Pearson correlations. A Spearman correlation is the non-parametric version of a Pearson correlation, and it is usually used when you have a multiple choice item that is ordinally measured, so it has hierarchy. A good example of that would be education, actually. If we swapped age with education here, and we did, is there a significant relationship between education and self-efficacy? That would likely use a Spearman correlation. And the reason for that is that education, it has a hierarchy to it, and that there's a bottom choice, there's a middle choice, and there's a high choice. There are multiple choices, but it goes up a ladder. It's ordinal in that format. So you would use a Spearman correlation. A chi-square test of independence is another test for a correlation, but it is used when you're testing the relationship between two categorical variables. So the sample question 2 would be a good example of that. Education is ordinal, but it's also categorical. It's not like it's a number, it's not numeric. Definitively, it's a categorical variable, and job position is also categorical. So you could run a chi-square test of independence to test the association between two categorical or nominal variables. Okay. So here we discuss the hypotheses. This is fairly straightforward. Once you understand how to do one set of hypotheses, the same logic applies. So we used that example before for a sample research question. Is there a significant relationship between age and self-efficacy? So you need to have two hypotheses. You need to have a null hypothesis, which is signified by this 0, H naught is what it's called, naught or 0. And you have HA, which is your alternative hypothesis. Generally, the null hypothesis is indicating that your relationship does not exist. You're not going to find significant evidence that there's a relationship, whereas the alternative hypothesis is indicating that, yes, we proved that there is a significant relationship between the variables. Okay. So when you do statistics, you're generally trying to prove that your null hypothesis is false. You want to reject your null hypothesis, which in turn means you're supporting your alternative hypothesis. That is generally the point of research, is trying to reject your null and prove the alternative. Okay, so the first correlational approach we designed or we discussed was the correlational analysis. The other branch from that correlational design is a regression approach. So a regression, the key word for a regression is you're trying to predict an outcome. You have an independent variable or a series of independent variables, and you're trying to predict a dependent variable. So the terminology that is often used with regression is a predictor, which is synonymous with an independent variable, and a criterion variable, which is synonymous with a dependent variable. Same meaning, it's just the terminology that is used. So a regression-based question has a similar format as what we just looked at. However, you have the word predict there. So you need to have an independent and dependent variable. You need to have something you're trying to predict. So in this case, the general research question will say, is there a significant predictive relationship between X and Y? So you just swap X and Y with your independent or predictor, and your dependent will go in the Y box, your dependent or criterion variable. So in this case, I gave some examples following that similar format. Is there a significant predictive relationship between age and self-efficacy? Age is going to be your predictor. Self-efficacy is going to be your criterion. You can also list multiple factors as predictors. and have an outcome or criterion that you're trying to predict. So in this case, maybe you're using the Maslach burnout inventory, the MBI, and you're trying to predict how does emotional exhaustion, depersonalization, and personal accomplishment significantly predict academic performance. And finally, we have an example here. Is there a significant predictive relationship between GPA and passing and failing a particular exam? Okay, so those are the three most common formats I've seen for listing predictive regression-based questions. From those, you can determine what type of analyses you're going to use. And for a linear regression, it is always based on how your dependent variable or criterion variable is measured. So first we have a linear regression or a multiple linear regression. If you see just a linear regression without the multiple, just a linear regression means you have one predictor predicting a criterion variable. If you have a multiple in front of it, that means you have multiple predictors trying to predict a criterion. So sample question 1 up here would just use a linear regression. Sample question 2, you have 3 different predictors. So that would be a multiple linear regression. And the reason it's a linear regression is because your dependent variable or criterion needs to be continuous. It needs to be a continuous measurement or interval ratio. So self-efficacy, and the example I gave here is, there are many questionnaires that can measure self-efficacy, but you're most likely going to have a series of Likert scale questions, and you would take an average or a sum of those questions, and that would represent self-efficacy. Once you take an average or a sum of Likert questions, that variable becomes continuous at that point, because the variable exceeds beyond just the anchors of the Likert scale. Like you might have 1 strongly disagree, 2 disagree, 3 neutral, and so forth. Once you take an average of a series of Likert scale questions, the possibilities for that variable go beyond the Likert scale anchors. So it could be, you could have a value 1.3, 2.5. You can have decimals. At that point, it's continuous. So you would use a multiple linear regression in that example. A binary logistic regression is used when you have a dichotomous outcome. So that means you have a 2-level outcome, and that would be like sample question 3 right here. So sample research question 3, how does GPA potentially predict passing and failing an exam? Your outcome in this example is dichotomous, meaning it has 2 possibilities, pass or fail. So in that case, you use a binary logistic regression. And then you have a multinomial logistic regression, which takes the same idea of the previous example, a binary logistic regression, but it's used when you have more than 2 groups. So instead of pass fail, say we swapped that variable with ethnicity. If you're trying to predict if GPA can predict what ethnicity someone is, Black, white, Asian, Hispanic, something like that. If you have 3 or more groups, you use a multinomial logistic regression. And finally, we have an ordinal logistic regression. So an ordinal logistic regression is used when you have an ordinal dependent variable. So a few slides ago, I gave an example of education being an ordinal variable. So if you were trying to say, does a predictive relationship exists between GPA and education level, then you would use an ordinal logistic regression because education has a hierarchy to it. It increases as you have more experience, so it is ordinal. Okay, so here, very similar to what I presented before, these would be sample hypotheses you would list. It's as easy as just copying your research question, and you have a null and alternative. You swap with the null, you put there is not a significant predictive relationship, and for the alternative, there is a significant predictive relationship. Okay, the next design or group of designs we'll look at here are experimental, quasi-experimental, and causal comparative designs. These all fall under a similar hierarchy, in that the goal of these designs is to test for differences. That's the key word here. You're testing for differences in variables between groups. So you need to have, again, an independent variable and a dependent variable. Your independent variable is going to be your grouping factor, and I'll discuss that more on the next slide. Your dependent variable is what you're trying to test for differences in or test for a change in. Okay, so here we have sample questions for this. So an experimental based question will generally follow this format here. Is there a significant difference in Y between the groups of X? So Y is your dependent variable and X is your independent. So it's a little bit different than the regression, excuse me, than the regression. You swap the position of your independent and dependent variable. Your dependent is going to come first. Is there a significant difference in your dependent between the groups of your independent? Okay, so there are multiple possibilities for these. You could say, is there a significant difference in job satisfaction between treatment and control groups? So maybe you're running an experimental study and you want to see if there are differences after an intervention between treatment and control. You could do this. A sample question would look like that. That is more of an experimental design because you're most likely going to randomly assign people to treatment and control groups. Quasi-experimental and causal comparative kind of go hand in hand. The general goal of it is to see if there are differences between variables, but the placement of people into different groups is decided before you make any manipulation. So, and a good example of that is research question 2. Is there a significant difference in self-efficacy based on race? Race is predetermined. You're not going to manipulate what group or what race participants are in. That is designated before you even begin the research. So that would be a good example of quasi-experimental or causal comparative. It's when the group placement is predefined. Sample question 3, you can have multiple dependent variables. So are there significant differences in emotional exhaustion, depersonalization, and personal accomplishment based on race? And question 4, are there differences, very similar to the third one, are there differences in the burnout constructs between race while controlling for job satisfaction? Okay, so I gave 4 possibilities here, and all 4 of those possibilities, just based on reading these questions, tie to specific analyses. So sample question 1, is there a significant difference in job satisfaction between treatment and control? In a case like that, you could just use an independent sample t-test because you have two distinct groups, and you're looking for differences in a variable between those two groups. And ANOVA takes the idea of a t-test, but it extends it further. It's when you're testing for differences between 3 or more groups. So is there a significant difference in self-efficacy based on race? That would use an ANOVA most likely. If you had white, Asian, Hispanic, and so forth, multiple races, you could use an ANOVA for that question. MANOVA is similar to an ANOVA, but you have multiple dependent variables. So you have the difference between research question 2 and research question 3 is that research question 3 has multiple dependent variables: emotional exhaustion, depersonalization, and personal accomplishment. And you're looking for differences in all 3 of those factors simultaneously between race. That would be an example of a MANOVA. And ANCOVA or a MANCOVA is exactly what these 3 research questions are, but you add on a control variable. That's what the C stands for. So let me go back a step. So ANOVA stands for analysis of variance. MANOVA stands for multivariate analysis of variance, meaning you have multiple dependent variables. And ANCOVA or MANCOVA, it stands for an analysis of covariance, meaning that you have control variables. So that's where you add a variable you want to hold constant and see if there are still differences in your variables between your factor. Okay, and then here we have the hypotheses for an experimental type design. So very similar. Is there a significant difference in job satisfaction between treatment and control groups? There is not, would be your null hypothesis. There is for your alternative. Sample question 2 is a little bit different in that you have 3 dependent variables: the emotional exhaustion, depersonalization, and personal accomplishment. You might want to examine all 3 of those separately, so you can have one sample question, but when it comes to the MANOVA, you run 3 separate tests. So you need to determine, are there differences in emotional exhaustion by race, but not depersonalization or personal accomplishment? So you need to examine each variable on its own. So typically, I would have a separate hypothesis for each of those dependent variables. So we have 3 sets of hypotheses, 3 sets of null and alternative hypotheses. Again, just saying there is not for your null and there is for your alternative. The final design that we have here, or the final common design that we see, is a longitudinal design. So a longitudinal design typically tests for differences in a value over time. So there can be an overlap. You can have an experimental longitudinal design, and that happens when you're doing a full-blown experimental study. You have treatment and control groups, and you have a pre-test and post-test. So it's possible that you don't have the treatment and control components. Everybody is participating in your education or intervention, and that would just require a dependent variable. So say you're giving you're testing for knowledge in nurses. Say everybody takes part in the education, you could give a pre-test to measure knowledge, and everybody's taking the intervention, then you measure all of their post-test scores at the end. That's when you just need a dependent variable. If in the same example, you had a treatment and control in the classroom. So a group of nurses, half are put in treatment, half are put in control. You have a pre-test, an intervention, and a post-test. Then you need that grouping factor, which would be treatment or control in this example. Okay, so a longitudinal design, the sample questions for this, very general, would be, is there a significant difference in y, being your dependent variable, between time period 1 and time period 2? Now from there, we can kind of expand it. So the sample question 1 is actually what I just indicated. So is there a significant difference in knowledge between pre-test and post-test of an educational intervention? Sample question 2 takes that idea a little bit further. So instead of just 2 time periods, you can have multiple time periods. You could have a baseline. This is very often used in the medical field and biology. So is there a difference between baseline, post-test, and then a follow-up that's done at some point in the future? So you have 3 time periods there. Sample question 3, is there a difference in knowledge over time and between groups? So that's more of a little bit more of a complicated example. Okay. So you have the time period component and you have a comparison between groups. So the most common longitudinal with a potential experimental component types of analyses are first, a dependent or paired sample t-test. I've seen it called both ways, dependent sample t-test or a paired sample t-test. So that would connect with the first sample question here. You're just testing for differences between 2 distinct points in time. A repeated measures ANOVA would be the appropriate test for sample question 2 because you have 3 time periods. So you could have 3 or more. You could have 10 time periods if you wanted. You could run it that way. A mixed model ANOVA is typically testing for interactions. So you have what's called a within effect. Are there differences over time? You have a between effect. Are there differences between your groups? And you have the interaction of those 2 concepts. Are there differences over time and between groups simultaneously? Okay, so the hypotheses are very straightforward. Again, you just say there is not a significant difference. And when you do experimental, causal comparative, longitudinal designs, difference is going to be your key verb that you use. That is the key word you need to have when you're using differences or you're doing an experimental design. You're testing for a change, so you need to say differences. And sample question 2 was, is there a difference in knowledge over time and between groups? So there, I mentioned on the previous slide, there are 3 components to this. Are there differences over time? That would be your within effect. That's the first set of hypotheses. Are there differences between treatment and control groups? That would be your second set of hypotheses. And is there a difference between time and group simultaneously? So you would have pre-test control, pre-test experimental, post-test control, post-test experimental. There are 4 possibilities there. So that's what this final hypothesis would test. And that's usually the goal of this research question. It's the best way to prove if the intervention was effective or not. Okay, so that pretty much covers the 4 designs and the different types of research questions and analyses. So just as a summary, the first thing, I know a few people did join a little bit late. So what I covered at the beginning is that you need to identify your problem statement and gap in the literature first. That needs to be the primary goal before even thinking about variables and research questions. You need to figure out what is the gap in the literature, then move forward from there. A good suggestion would be to look at the ends of articles that you're reading that maybe you found a topic you're interested in. Towards the end of many articles and journal publications, they give recommendations for future research. That is a good starting point where you can build your research off of those recommendations. And then once you've gone through the literature, you've developed your problem statement, you know there's a gap in the literature, determine whether you can address your purpose and problem statement quantitatively or qualitatively. Quantitative uses statistics and numbers, closed-ended responses. Qualitative is more open-ended, examining the perceptions of participants at a deeper level. Then you need to identify your variables of interest. If you select quantitative, identify your variables of interest and determine what the level of measurement is for every variable. So it can be nominal, which is categorical, like ethnicity. It can be ordinal, which means it has a hierarchy to it, like education, or it can be interval, something like GPA, or if on a survey you ask for someone's age specifically, that would be interval. Then you need to determine whether data is going to be collected through a survey or archival secondary data. A survey, if you do select a survey, it needs to be closed-ended responses. Try not to have open-ended responses. Try to use a previously validated survey instead of developing your own, because you have to do a pilot test and prove that it is valid and reliable in that case. So just to expedite the process, I would say use a survey that is validated or use archival secondary data. Then select your research design. So we discussed exploratory, correlational, we have experimental, quasi-experimental, causal comparative, and longitudinal. So exploratory is just looking for trends, being the keyword, just examining trends. Correlational is either looking for two-way relationships or trying to predict a relationship. Experimental, quasi-experimental, and causal comparative, and longitudinal. You can put longitudinal in that group, but those are generally looking for differences, where longitudinal is looking at differences over time. It can have an experimental component where you have treatment and control groups. And then once you've identified your research design, you can develop your research questions and hypotheses and determine the appropriate statistical analyses that can address those questions. All right, well, thank you for joining. I'm going to do a question and answer session shortly. Just to reiterate, we do help with all portions of the dissertation process, from topic development through the end. So if you need help developing your research questions, if you need help selecting a gap in the literature, do you have a good topic, a solid theoretical framework? We help with quantitative and qualitative studies, IRB forms, entering data. We have our own SurveyMonkey account, so we can host your survey for you if you sign on for the results chapter. And then we help with the discussion, which is connecting your findings back to the literature, presenting limitations and recommendations for future research. And we help with PowerPoints for the defense and journal publications. So I do have a link down here, and I'm going to send this to everybody.